Mortise and tenon joinery has been in existence for centuries. The joint consists of a tenon in one member which fits into a mortise of an adjoining member. The tenon also has shoulders which keep the tenon locked in squarely to the mortise. When the tenon fits into the mortise snugly, the joint is exceptionally strong. The components of a mortise and tenon joint are shown here. The mortise and tenon joint is resistant to the 4 types of stresses discussed in an earlier lecture. Mortises can either be created using hand tools, with a router setup, or through the use of a mortising machine. The mortise is created first, and the tenon is then fit. Both the mortise and tenon are initially laid out on adjoining boards. Scribe lines are then created, and the mortise and tenon can begin to be shaped. Shown is the process of creating a mortise, using a series of holes drilled along the side of a board. There are different methods of creating a tenon. The most basic method is through the use of hand tools, namely a small tenon saw. The most common method, however, is through the use of the table saw. The cheek of a tenon runs parallel to the grain of the wood, whereas the tenon runs parallel to the end of the board or across the grain. The illustration shows the cuts necessary in the creation of a tenon. This illustration shows how a tenon fits into a mortise. As well, the tenon is pegged afterwards. Inserting pegs into a mortise and tenon joint ensure that there is a mechanical lock between the 2 components. Otherwise, only glue holds the components together. A detailed view of pegging a mortise and tenon joint is shown here. The peg is driven through both the mortise and tenon, essentially locking the joint together. The hole for the peg is also known as a draw bore. The next series of illustrations shows how both a mortise and a tenon are created using hand tools. A set of mortising chisels will be necessary to hollow out the mortise. These chisels have thick shanks and are square in dimension, ideally suited to mortising. The mortise is methodically chopped out as shown. Laying out the mortise is critical when creating mortise and tenon joinery. Once the lines are scribed for the outline of the mortise, the waste wood is chopped out in layers. A sequence of vertical and angled chisel cuts are performed until the mortise is at the correct depth. The depth of the mortise is regularly checked. It is important not to exceed the marked depth since it might be close to the backside of the component. The walls of the mortise are also checked to determine that they are vertical and square. In this illustration, the tenon is being cut. It is initially marked and the saw lines are accurately transferred onto the wood. The cheek is cut first in this sequence. The depth of the cheek will be sawn just short of the marked shoulder line. Once the cheek has been sawn, the shoulder is cut next. It can be seen that the saw cut of the cheek is just short of the shoulder. The saw cut curve of the shoulder will intersect the saw cut of the cheek. It is important to ensure that the saw cut of the shoulder is perpendicular to the cheek. A haunch is cut next. Cutting a haunch is a technique used to bring the board with the tenon up to the edge of the mortise board. The haunch effectively reduces the width of the tenon from the full width of the board to a smaller width, as shown. The tenon is now test fitted into the mortise, and any necessary paring is performed using a chisel. Once the tenon has been correctly fitted into the mortise, the peg or draw bore holes are bored into the tenon. These holes can also be slightly skewed from the holes in the tenon to effectively draw the tenon further into the mortise and to lock it securely. Shown is a mortising machine. The square mortise is created through a combination of chisel and drill. The drill bores a hole and the square chisel pairs the corners to effectively create a square hole. The motor assembly contains the drill chuck as well as clamping the chisel. The long lever seen is used to pull the assembly into a board, which is securely clamped to the fence. The workpiece is held tightly against the fence here. The front jaw is used to perform the clamping. The narrow arms just above the workpiece are adjusted to keep the workpiece locked down, since the chisel can easily pull the workpiece up when the chisel is withdrawn. The mortising machine has an adjustable depth stop as well as stops from side to side. It can be seen that this machine is specifically designed to create square mortises. The chisel and drill combinations are available in a range from 1/4 inch up to 1 inch. An efficient method of creating tenons is to use the table saw and a special tenoning jig. The board where the tenon is to be created is clamped vertically as shown. The tenoning jig allows for precise micro adjustments from side to side. This feature ensures a very precise tenon width. The tenoning jig fits into the miter gauge groove and is moved forwards and backwards into the saw blade. The short shoulders of the tenon are cut with a small tenon saw afterwards. In this view, the precision of the tenoning jig can be seen. The height of the table saw blade is set to the depth of the tenon. It is recommended to create the tenon a hair thicker so it can be pared and adjusted into the mortise using chisels. This will ensure a tight fit. With practice, this jig is a valuable time saver in the workshop. The adjustments for the tenoning jig are shown here. The micro adjust knob can be seen. As well, the adjustable fence is seen, which can be tilted for angled tenons. In most cases, the tenon width is centered in the board, so it becomes a matter of flipping the board around to create an identical cut on each cheek. A typical mortise and tenon joint is shown here. These tenons have 4 shoulders to completely house the cheeks within the mortise. Although 4 shoulders are more work to create, this type of joint is more aesthetically pleasing. It can be seen how the cheeks are completely housed in this view. 4 shoulders are cut around the tenon to perform this. In this example, the tenons are also set back from the edges of the mortise. This is often used when one member is thinner than the other. A double mitered mortise and tenon is shown here. This is a variation of the straight mortise and tenon and is a more aesthetically pleasing joint. This joint is also strong since the tenon and shoulders do not twist in the mortise. The double mitered mortise and tenon shown again, but assembled. It can be seen that this joint, once assembled, can be very strong and rigid. Shown is the corner mortise and tenon. This type of mortise and tenon is often used to connect table aprons to a leg. The ends of the tenon are mitered to fit better within the mortise. The corner mortise and tenon seen again, but assembled. Once the tenons are inserted and glued, this joint is very strong. The individual aprons also fit neatly into the table leg. A set of 4 legs and 4 aprons for a cabinet stand are shown. The leg mortises are similar to the mortise shown previously. The tenons of the aprons have pencil marks, where the ends of the tenons will have miters created. These miters are created to be able to fit 2 aprons into 1 table leg. Another view of the 4 legs and 4 aprons is shown here. The mortises have been created using the mortising machine, and the tenons were cut using the tenoning jig shown earlier. The apron tenons have now been mitered and test fitted. Also shown are a set of 4 lower stretchers for the cabinet stand. The lower stretchers are attached to the legs using hidden dowels. The cabinet stand has been assembled and glued here. It can be seen how the corner mortise and tenon joint is an effective joint for this type of table construction. An example of a haunched mortise and tenon is shown here. The mitered haunch is used to hide the top part of the tenon from the top of the adjoining member. Once the tenon is correctly fitted into the mortise, the topmost pencil line will determine where the mortise is to be trimmed. A more detailed view of the haunched mortise and tenon. The miter at the top of the tenon effectively hides the tenon from the top of the mating mortise. The topmost part of the mortise, at the pencil line, is to be removed after fitting. Another detailed view of the haunched mortise and tenon. The topmost part of the mortise, at the pencil line, is sawn off after fitting. Creating this joint is a little more time consuming, but the advantage is a more aesthetically pleasing joint. Shown is a typical application for a haunched mortise and tenon joint. The small notch stub at the top of the tenon hides the groove along the length of the mating member. A groove is created in each of the 4 sides to accept the floating panel. In this photo, the groove can be seen in detail. The missing member also has a groove which is covered by the small stub tenon or haunch. This describes the most common application of the haunched mortise and tenon. In this photo, the stub of the tenon can be seen precisely fitting into the groove of the adjoining board. This allows the full tenon length to be inserted into a mortise, while the shorter stub tenon fits into the groove for the panel. Another variation of the mortise and tenon is shown here, the mitered corner with through tenon joint. This joint provides the strength and rigidity of a through tenon into a corner miter joint. The mitered mortise is created on a table saw, and the 45-degree mitered tenon is created using the tenoning jig set at a 45-degree angle. Another view of the mitered corner with through tenon. The joint is assembled in this view. The mitered mortise is created by creating a regular mortise in square stock and then mitering the corner at 45 degrees. Shown is an example of a through wedge tenon. The small contrasting wedges reinforce the tenon in the mortise and are installed after the tenon is inserted. Two small triangular curves are created along the length of the tenon, and small wedges are inserted and hammered in during glue-up. The wedges are trimmed once the joint has cured.